The Bell-Boeing V-22 Osprey is an American multi-mission tail-rotor military aircraft with both vertical takeoff and landing and short takeoff and landing capabilities. It is designed to combine the functionality of a conventional helicopter with the long-range high-speed cruise performance of a turboprop aircraft. The failure of Operation Eagle Claw during the Iran hostage crisis in 1980 underscored the requirement for a new long-range, high-speed vertical takeoff aircraft for the United States Department of Defense. In response, the Joint Service Vertical Takeoff Landing Experimental Aircraft Program started in 1981. A partnership between Bell Helicopter and Boeing Helicopters was awarded a development contract in 1983 for the V-22 tail-rotor aircraft. The Bell-Boeing team jointly produced the aircraft. The Osprey is the world's first production tail-rotor aircraft, with one 3-bladed prop rotor, turboprop engine, and transmission nacelle mounted on each wingtip. It is classified as a power-lift aircraft by the Federal Aviation Administration. For takeoff and landing, it typically operates as a helicopter with the nacelles vertical and rotors horizontal. Once airborne, the nacelles rotate forward 90 degrees in as little as 12 seconds for horizontal flight, converting the V-22 to a more fuel-efficient, high-speed turboprop aircraft. Composite materials make up 43% of the airframe, and the prop rotor blades also use composites. For storage, the V-22's rotors fold in 90 seconds and its wings rotate to align, front to back, with the fuselage. Due to the requirements for folding rotors, their 38-foot, 11.6-meter diameter is 5 feet, 1.5 meters less than optimal for vertical takeoff, resulting in high disc loading. Most missions use fixed-wing flight 75% or more of the time, reducing wear and tear and operational costs. This fixed-wing flight is higher than typical helicopter missions, allowing longer-range line-of-sight communications for improved command and control. The 400th Bell-Boeing-built Osprey was delivered to U.S. Air Force Special Operations Command to support a wide range of mission sets including troop transport, resupply, and long-range infiltration. The Osprey has supported land and maritime combat and land war for many years since its arrival more than 10 years ago. Its mission success has inspired the Pentagon to continually upgrade the aircraft for service as far as into the 2050s and beyond. The longevity and expected service life of the Osprey has, for many years, been supported by a wide range of sustainment and modernization efforts, including aerial refueling and advanced digital networking. There is also the possibility of further arming the platform, and the Navy has been working to engineer and deploy its own variant of the Osprey. The CMV-22B Navy variant, in development right now for several years, is intended to replace the current role of the carrier-launched C-2 Greyhound aircraft. The military services who operate the Osprey have over the years added a digital interoperability technology to network the aircraft, its crews, and other air and ground nodes to transmit combat-crucial real-time intelligence information. Exhaust heat from the V-22's engines can potentially damage ships' flight decks and coatings. Naval Air Systems Command, NAVAIR, devised a temporary fix of portable heat shields placed under the engines, and determined that a long-term solution would require redesigning decks with heat-resistant coating, passive thermal barriers, and ship structure changes. The V-22's two Rolls-Royce AE 1107C engines are connected by drive shafts to a common central gearbox, so that one engine can power both prop rotors if an engine failure occurs. Either engine can power both prop rotors through the wing drive shaft. However, the V-22 is generally not capable of hovering on one engine. Due to its tilt-rotor configuration, the Osprey can hover in helicopter mode for close-in surveillance and vertical landings for things like delivering forces, equipment, and supplies, all while being able to transition into airplane mode and hit fixed-wing aircraft speeds. This gives the aircraft an ability to travel up to 450 nautical miles to and from a location on a single tank of fuel, Corps officials said. The V-22 can be armed with one 7.62 by 51 mm NATO, .308 in caliber, M240 machine gun, or .50 in caliber 12.7 mm M2 machine gun on the rear loading ramp. A 12.7 mm .50-inch GAU-19 three-barrel Gatling gun mounted below the nose was studied. BAE Systems developed a belly-mounted remote-operated gun turret system, the Interim Defense Weapons System (IDWS). It is remotely operated by a gunner. Targets are acquired via a separate pod using color television and forward-looking infrared imagery. Over the years, the Naval Surface Warfare Center and various industry partners have explored the possibility of more fully arming the Osprey with new weapons, giving its fast-expanding combat roles. At one point, various services were exploring requirements along those lines. However, the status of such an initiative is, at the moment, unclear. At one point in recent years, industry experimented with firing 2.75 folding-fin Hydra 70 laser-guided rockets to support the aircraft's mounted guns. The high-speed version of the hose drogue refueling system can be deployed at 185 knots, 213 miles per hour, 343 kilometers per hour, and function at up to 250 knots, 290 miles per hour, 460 kilometers per hour. A mix of tanks and a roll-on, roll-off bladder house up to 12,000 pounds, 5,400 kilograms of fuel. Adding weapons to the Osprey would naturally allow the aircraft to better defend itself should it come under attack from small arms fire, missiles, or surface rockets while conducting transport missions. In addition, precision fire will enable the Osprey to support amphibious operations with suppressive or offensive fire as Marines approach enemy territory.